So in this video, we are going to discuss that if there is any second order differential equation with constant coefficient, uh, how to find particular integral if this x means this rx part, right hand side part is a pure trigonometric function like sin x cos x or a polynomial function. Okay. So suppose the given differential equation is this. So we can write this differential equation in the form of f of d y equals to x. So in this case, our particular integral will be 1 by f of d x, and we can write f of d in this form. Okay, where x is a polynomial function. Okay. So before going to explain how to apply this for a polynomial function, uh, let me discuss the expression of 1 plus x minus 1, so which is equals to 1 minus x plus x square minus x cube up to infinity. And 1 minus x whole to the power minus 1, it will be 1 plus x square plus x cube up to infinity. Okay. So let me discuss this method with few examples. Here the given differential equation is d square y dx2 plus y equals to x plus 1. Okay. So we write this differential equation in the form of d square plus 1 y equals to x plus 1. Okay. So in this case, the particular integral will be 1 by d square plus 1 into x plus 1. Okay. So we can write this d operator in the form of 1 plus d square to the power minus 1 into x plus 1. So we know that 1 plus x to the power minus 1 is 1 minus x plus x square minus x cube up to infinity. Okay. So in the place of x, if I put d square, so it will be 1 minus d square plus d to the power 4 minus d to the power 6 up to infinity, and the given function is x plus 1. Okay. So here we know that d is basically this operator ddx. Okay. And if we derivative this function, means if we apply this operator once on this function, it will be equals to 1. And if we apply this operator on this function x plus 1 twice, it will be 0. Even we can say that for any higher order derivative of this function is 0 for each n greater, strictly greater than 2. Okay. So if I multiply this 1 with x plus 1, it will be x plus 1. And after that, each and every term, it will be 0. So therefore, for this problem, our particular integral will be x plus 1. And I hope you've already calculated the YCF. What will be the YCF? For that, you have to first calculate auxiliary equation. So for this problem, our auxiliary equation will be n square plus 1 equals to 0. So therefore, the value of n will be plus minus I. So the YCF means complementary function will be C1 cos x plus C2 sin x. Okay. So for this problem, our general solution will be y equals to YCF plus YPI. So YCF is C1 cos x plus C2 sin x, and YPI is x plus 1. And you have to mention that C1, C2 be arbitrary constant. Okay. So in this way, try to solve the next problem. So it's a similar type of problem. So here the given differential equation, we can write this equation in this form: d square plus 4d plus 3y equals to x square plus 1. Okay. So I hope you can find the complementary function. Let me just discuss the particular integral. Okay. So here the particular integral will be 1 by f of d. So f of d is d square plus 4d plus 3, and the given right hand side part is x square plus 1. So basically x square plus 1 is a polynomial function. Okay, and write this d square plus 4d plus 3 in the form of 3 in bracket 1 plus d square plus 4d by 3, because we have to express this d operator function in this form for polynomial. Okay, so that's why we take 3 common here. So ultimately it will be 1 by 3, 1 plus d square plus 4d divided by 3 whole to the power minus 1. Okay, now if we write this in binomial expression, so it will be 1 plus, sorry, 1 minus x. So our x is d square plus 4d by 3 plus x square. So it will be d square plus 4d whole square divided by 9 minus up to infinity. And the given polynomial function is x square plus 1. Okay. Now, roughly you have to check that if we derivative this given function, polynomial function once, so it will be 2x, and if we derivative this x square plus 1 twice, it will be a constant. And after that, each and every higher order derivative will be 0. Okay. For this reason, just we have to take up to third term, because in third term, the index value is 2. In next term, the index value will be 3. And there, each and every function, if you write dq, this value is 0. So just we have to take this 3 term. Okay. Now, if we multiply 1 with x square plus 1, it will be x square plus 1. And in the place of d square, we can directly write 2, because we know that if we derivative this twice, it will be 2. So we can directly put 2 here plus 4 into the value of first order derivative of the given function, which is 2x divided by 3 plus. So in the third term, this value, it will be 16d square. So that's why I write 60, and the value of d square is 2, means d square, not d square x square plus 1, it will be 2. So directly we can put 2 here divided by 9. So don't need to write x square plus 1 here. So now just simplify this. You can just subtract this minus 2, 3 from 32 by 9, and you can easily find the particular integral. And to find general solution, you have to add this to function. If the right hand side part is a purely a trigonometric function of sin x or cos ax, so how to find particular integral? So the particular integral will be 1 by f of d sin ax plus b. Okay. So here, anyhow, we have to make this d operator as a function of d square. And the particular integral will be 1 by this phi of minus a square if this value is not equals to 0. Okay. So for trigonometric function, cos x and sin x, if there is any suppose there is a d operator f of d, we have to make this function as a function of d square. Then we can put this value, means we can replace this d square by minus a square if this value is not equals to 0. Okay. And if this value is equals to 0, and suppose this value phi of minus a square is equals to 0, then it will be x into 1 by f dash d sine ax plus d. Okay. Now try to understand this method with few examples. First problem is d2y dx2 plus y equals to sine 2x. Okay. So I hope you can find the complementary function in this way. Okay. So let me just discuss the particular integral. What will be the particular integral here? So it will be 1 by d square plus 1 sine 2x. Okay. So roughly we have to check that if this value, means basically it's a function of d square, so don't need to modify this function. So now we can directly replace this d square by minus a square. Okay, here the value of a is 2. So if we replace this value d square by minus a square, it will be minus 2 square plus 1. So ultimately the resultant value is minus 3, which is a non-zero value. Okay, so since this value is a non-zero value, we can directly put the value here. So the particular integral will be minus 1 by 3 sine 2x. Okay, so therefore the general solution of the given differential equation will be YCF plus YPI. Here the YCF is this function and YPF PI is minus sine 2x by 3. Okay. Now pause this video and try to find the general solution of this problem. So here the given differential equation, we can write this given differential equation in the form of d square minus 3d plus 2 into y cos x. So therefore it's very clear the value of a is equals to 1 here. Okay. So therefore for this particular problem, the YPI will be 1 by d square minus 3d plus 2 into cos x. So what we can do, because it's not only a function of d square, it's a basically function of d square and d. Okay, so we can at least replace this d square by minus a square. So now if we replace this d square by minus a square, it will be minus 1 square minus 3d plus 2. So therefore in next step we can write 1 by 1 plus 3d into cos x. Okay, but we have to, anyhow we have to write this or modify this function as a function of d square so that we can apply this rule. Okay, now if we multiply 1 plus 3d in numerator and denominator, so it will be 1 plus 3d divided by 1 minus 9d square into cos x. Now again if we replace this d square by minus 1 square, it will be 1 by 10, and here it will be 1 plus 3d cos x. Okay, now just in next step we can write 1 by 10 and it will be cos x plus 3 into derivative of cos x, it will be minus sin x. Okay, so for this problem, our particular integral will be this function. Okay, so to find the general solution, just you have to find the complementary function and plus the particular integral is this function. Okay, so now it's a similar method. Pause this video and try to find the general solution of this problem. So I hope you can easily find the complementary function for this problem. But here the d operator function is d square plus 9. So roughly, let me check is this value is equals to 0 or not if we replace this d square by minus a square. So it's very clear the value of a is 3 here. Okay. So if we replace this d square by minus a square, it will be 0. Okay. So we can't apply the previous method here. What we can do? We can apply the second method. It say that just you have to write x into derivative of this function d square plus 9, which is 2d into cos x. Okay, so in next step we can write x by 2 1 by d of cos 3x. Okay, so this d is basically this operator, derivative operator. Okay, so what will be the 1 by d operator? It's actually integration. Okay, so if there is any 1 by d function, we can directly integrate this function cos 3x, and the integration will be sin 3x divided by 3. So therefore for this problem our particular integral will be x sin 3x divided by 6. Okay, so for general solution general solution, first you have to find the complementary function, and here the particular integral is this function. Just put the value here. Okay. And you have to mention about C1, C2. That this C1 and C2 are arbitrary constant. I hope these two methods are clear.